this lecture in cybercrime and digital evidence. This is the third lecture in our series. It provides an introduction to some of the key concepts in the identification and collection of digital evidence, a practice we know as digital forensics. Digital forensics can be broken down into 4 primary subdomains. Each looks at different types of digital artifacts, and each requires different collection and analysis skills, different methods, and presents with unique technical issues and challenges. Computer and storage forensics have changed dramatically during the last decade, and mostly as a result of miniaturization and integration. While there was once a time where we could have extracted the hard drive from a computer and cloned it using tools and equipment that were common to the workbench of almost every computer lab, computers like your new MacBook Pro laptop that once used to have separate processors and memory chips and hard drives now have all of these components integrated into a single circuit board. And in some of the newer system-on-chip approaches, like that used in the new Mac Studio, they're integrated into a single chip. Many of these new motherboards contain all of the equipment that was once housed in a large tower computer case even 10 years ago, all contained now within the integrated motherboard that can be not much larger than 2 standard playing cards. Network devices are often overlooked when we seek to identify the systems used and the perpetrator of a digital crime. Many network switches and routers contain logs that can identify the source and destination user devices, the applications that were used, and other details that can effectively provide an understanding for how someone on a computer in place A communicated with and transferred data to or from a computer in place B. These logs can also be exculpatory, especially when they're shown to be both valid and contiguous, but they don't contain the information necessary to demonstrating the prosecution's version of events. Mobile forensics are perhaps the most complex, as they deal with similar artifacts, but all of the concomitant issues of every other digital forensics domain combined. In any given investigation, you may be presented with the records and reports that fall within one or all of these digital forensics domains. The overall process of digital forensics involves 5 principal steps that in most cases only occur well after the crime has been committed. The first step involves identification of any digital evidence that may be present at the crime scene or that may have been created during commission of the crime. This could include physical devices like a USB drive or a hard disk, or other devices that store data like an iPad or a smartphone. Or it could be digital assets like files stored in cloud accounts, metadata from the ISP or the mobile telephony provider, or black box data from a modern motor vehicle. The second step, acquisition, directly precedes the first. Now, care should be taken to identify the powered state of a device, as the processes that need to be followed are entirely different depending on whether the computer is found in an on or off state. A record must be produced describing what was identified for acquisition, where it was found, and its disposition when it was located, as well as any instant searches that were conducted of the device. For example, if one of the police detectives sat down and looked through some of the files or folders on the computer. The most important thing is to ensure the integrity of the data stored in the device and that it remains intact. Acquisition first requires securing the crime scene to ensure the data or devices on which the data might be stored cannot be tampered with, after which the data must be forensically acquired. The acquisition method used will depend on whether the data is being sourced from a volatile or non-volatile source. Volatile sources are those that, for example, like the short-term memory in your computer, will lose data as soon as the power source is removed. Non-volatile sources are those like a hard drive or a USB stick on which the data is persistent between power cycles. For volatile data, that is the data that would be lost if we turned the computer off, some manuals recommend imaging the address resolution protocol or ARP session data. This is the network data to do with the computers that this computer has interacted with. That followed by the login session data, a list of running processes, and open files, and then imaging of the random access memory. A different strategy is used for non-volatile storage devices like your hard drive, which these should be bitstream imaged using a forensics tool like EnCase that will take an exact replica of every sector and block on the physical drive at the hardware level. These bitstream images can make hidden partitions and files that may be invisible to the source computer's operating system visible to your forensics data analysis tool. Next, the evidence collected must be preserved in such a way as to ensure its integrity and that it remains the same even after the examination has concluded. The chain of custody must also be maintained. Read-only copies should be provided to practitioners and their experts to work from, while the original source should be kept secure and protected from any unintended alteration. Analysis initially involves categorizing the evidence and the type of tools that will be required to examine it. For example, text messages can involve tools to image or extract them from phones and integrate them with the metadata that includes the sender's subscriber or telephone number, the time the text was received, and the network that it came from. However, different tools would be necessary to examine the content and metadata of a digital photographic image versus, say, an email message. Correctness and authenticity depends solely on the expertise and skill of the person who's examining the evidence. Finally, presentation of the evidence entails multiple steps that start with an initial report to the legal practitioner that can lead to a request for a formal statement. Such reports frequently describe the tools and methods that were used, the protocols or legal policies applied, and, depending on the court's requirements, may present these in a specific format. And if the matter eventually goes to trial, presentation of the evidence is the last step. Digital forensics techniques may be used by digital investigators, IT security officers, corporate security investigators, and even police. Some matters that complicate digital evidence gathering and analysis include the fact that storage devices like USB drives, hard drives, network storage devices, and cloud servers are now typically quite large, and they can contain a lot of data. There is often a very large amount of digital evidence that needs to be processed and analysed, and with the pressures of prosecution these days, a very short amount of time to do it in. It always remains the responsibility of the evidence gatherer to identify what relevant evidence might exist and to recover that evidence in a sound manner. The digital forensics investigation process must maintain and be able to prove the integrity of the digital evidence in order to ensure admissibility of that relevant digital evidence in a court. Some important considerations for interrogating the digital evidence that you may be presented with in a case include asking whether or not all of the relevant sources of digital evidence were identified and whether or not they've been handed over in discovery. Second, you might also ask whether or not that digital evidence can be authenticated and whether or not there's accurate documentation of all of the steps that were undertaken to identify and collect it. Now, the process of authenticating digital evidence is usually done using hashes, and the concept of hashing data is where we use a mathematical algorithm to generate a fingerprint for that data. The hash value is referenced by the digital forensic analyst whenever data is processed or copied to ensure that the data that's being copied authenticates back to being identical to the original source data. Hash values do not change when the metadata of the file changes, so the time and date, for example, that the file was written to the device. Hash values also don't change when we rename that file. However, the hash value will change if any of the content of the file is changed. So, for example, if we're using a Word document and somebody opens that Word document up and adds a full stop, a period to the end of a sentence, then the hash for that entire Word document will change because of the presence of that full stop. Without a proper preservation methodology, there's no way to defend a challenge to the authenticity of electronic evidence, and you may then jeopardize the admissibility of that evidence in court. Third, were redundant copies of the evidence made during acquisition? Now, normally during acquisition of electronic evidence, or immediately after it, we will copy and secure that electronic evidence on two separate pieces of media. That's on top of the original source. So we have the source, which once it's copied, we wrap it up, we put it away. We have the first copy, which we label as the original copy, and then the second copy we label as our working copy. No analysis should ever be done using the defendant's original source material. No work should ever be done using the original copy. All of our work is done using the working copy. And that's so that if anything happens to that working copy, we can go back to our original copy and make another copy, or at the end of our analysis, we can do a compare between the working copy and the original copy to demonstrate that the two are still identical. Number 4, we might be interested in the chain of custody, whether it's been properly maintained and whether it's complete and accurate. Now, the chain of custody for a particular piece of evidence is established at the time you acquire the evidence, and it should start with the location and the access at the time that that evidence was acquired. For instance, if somebody was to leave a smartphone at the scene of a crime and it was provided to us by the police for preservation, so we've bagged it up, the custodian of the smartphone, so the analyst, the digital forensics technician who's collected it, will bag it. We will seal that bag and we'll put the time and date and where it was acquired from. We may even take photographs. Once that smartphone is then received by somebody else in the lab, a receipt is generated. And once they will open it, they will do their work on it. And once they return it into evidence, that receipt is then closed out. At this point, the acquired electronic evidence has been tracked through a chain of custody. Part of that process means then that we can go to a particular person who had it at a particular time and ask them, right, what is the process that you used? Because they should be documenting all of the analysis steps that they performed. What is the process you used on it during the period that it was in your care? And this slide is an extension of the last slide. The good lawyer should always ask questions of any evidence being adduced. But these questions that you see here are some of the ones that are especially important when you're looking at digital evidence. So we might ask, how do we know the data hasn't been tampered with? Well, again, you'd look at your chain of custody, you'd look at who had it, what processes were performed on it, whether or not at the end it can be verified back to the original. Who had the ability to access the files before or after they were collected? In several cases, the digital evidence was thrown out of court because it was demonstrated that either the defendant themselves or the police had sat down and interfered with the computer before the digital forensics expert was on site. Are any provided date stamps accurate? An interesting issue in one of the cases you'll look at later is that some digital evidence was printed out that had date stamps on it that were 3 months after the crime was committed. How do we know the data was recorded accurately? Has the forensics expert provided us with documentation that shows us the steps and identifies the tools that were used to acquire the evidence? Could any of that data, could any of the evidence have been faked? It may seem far-fetched, but it has happened from time to time, and it's an especially used process perhaps in Australian and American investigations. The FBI use it quite a bit, where they will remotely access they'll get a court order and remotely access a target of interest's computer system to see what's on the computer system. Now, several of those cases have been, the evidence has been dismissed from the trial because the FBI officer could not demonstrate that they hadn't manipulated any of the data during the time that they were remotely connected. What media was the file recorded onto originally? I.e., was it a worm drive, which is a write-only, write once, read many type drive? Was it a hard drive? Was it a solid-state drive, a USB stick? Was the media that the evidence was on during analysis, was it media that was write protected, or was it able to be changed? Is it possible the analysis process changed anything? What has been the chain of custody for this digital evidence from the time it was acquired to now? Is that chain of custody complete? Can we show every time it's been in and out of the evidence room? What experience did the officers or the forensics person have in obtaining legal evidence? What experience did they have specifically in obtaining digital evidence? And are there any potential sources that are possibly corroborating or refuting evidence that were missed during the collection process? The key message here for you is to always be both skeptical and analytical. And that goes not just for digital evidence, that goes for all evidence. Always be skeptical and think that, go through the process, ask the questions. Don't assume that the other side, what they're giving you, is 100% totally accurate. And always be analytical. Always be looking for the potential for something to have been missed or something not to have been done right. We're now going to change tack a little bit, and I'll take you through a couple of potential digital evidence scenarios. So this first one here, let's take our friend, we'll call him Tim. Tim decides that he's going to sit at home and hack into one of the local bank's computer systems and do what all of us would like, add a couple of zeros to his bank balance. What potential sources of digital evidence do you think might be available to support Tim's prosecution? Pause the video here while you consider your answer. First, you'd obviously want to collect the network and browser logs and the browser history from Tim's computer. You might also find on his computer some source code for the attack or the software that Tim used to access the bank's system, or whatever it was that he used to affect the bank balance of his account. We would generally take the entire computer and image any data storage devices like hard drives within a forensic software tool like EnCase. Now, as we discussed before, that's a type of forensics tool that allows for imaging and analysis of the data contained within the hard drive at the bit or the hardware level, and in a manner that's not directly using or compromising the source data. Similarly, you'd also seek to secure the network, firewall, web server and database logs from the bank's servers, as well as any digital records for the account systems such as the statements or transaction records. Another potential source that's often forgotten is the internet service provider. Their logs can establish the connection between Tim's home router and the bank's network, and they'll provide you with an additional source to demonstrate that at the times shown in the bank's logs, there was traffic going between Tim's house and the bank. Now here's a second example. In this example, Julie has a car accident in the main street of her town. What potential digital evidence sources do you think might be available that could provide relevant evidence that supports either a prosecution, a defence, or a civil claim? Again, pause the video here while you consider your answer. First, potential sources could include building security, crossing, and traffic cameras. Each of these is a potential digital video source that's capable of showing some or all of the events that led to or occurred during or after the accident. This also includes speed and red light cameras. Many people are unaware that these cameras, which are typically called GATSO cameras after the company who created some of the first ones, often record a live feed. Even though they'll usually only flash when a vehicle's going too fast or proceeds through a red light, many use technology like ANPR on the live feed and are recording that feed and processing the number plates, and the number plates are recorded with their time and day in a database. Sometimes it's even within a local or municipal data set. A third potential source, obviously, is the devices and social media accounts of any bystanders who may have captured images or video of the incident. And finally, don't forget that most vehicles manufactured in the last 20 years have some form of black box that records the metrics about the vehicle's current orientation and any driver inputs. This data can assist you to understand the conditions and the experience of the vehicle and the actions that were taken by the driver. There may also be dashcam video, either from the driver-added equipment or, in the case of some newer vehicles, captured automatically by the 360-degree parking systems that are installed by the manufacturer. Now, in our third and final scenario, this is the Therac 25 computer-controlled radiation therapy machine. This machine was used up until about 15 years ago to provide radiation therapy to cancer patients. We still use machines like this, we just use more modern, newer versions of machines like this. Now, this machine, this particular unit, is no longer in use because during 1985 to 1987, at least 6 people were given massive overdoses of radiation due to programming errors that were exacerbated by operator error. If you were a lawyer suing the manufacturer, the hospital, and the operator for negligence, what sources of digital evidence might you use to prove that your client received an overdose from a similar machine today? Pause the video here and consider your answer. First, even though you might already be able to identify the treating radiologist, you might look at the network connection logs to ascertain which hospital workstation was used to send the treatment plan coding instructions to the machine and when. This information would give you sufficient detail to then know when and where to look in the hospital workstation logs to verify firstly that this computer was used to send the treatment instructions and that the system and user logs identify a user account that was signed in at the time of that workstation and at the time the treatment instructions were transmitted to the machine. You might also collect details about the software version, how the software was being used at the time from the software logs, and potentially even in this case the source code. Next, you might go to the hospital servers to link the user account to a staff member's identity, and in many cases other items like their security and computer access cards. You might collect the authentication, access and audit logs, the AAA logs, that identify whether the user account was verified via the hospital's authentication servers and the records of what files, patient records and network applications they were using at the time the event occurred. You might also cross-validate by checking the security logs to see whether the identified user and anyone else had used their security pass to access the secured areas at the time, because in most hospitals the workstation room where these workstations are kept that program your MRI or your CAT scan or your radiation machine and the radiation machine themselves will be swipe card coded and they'll be kept locked so that people can't interfere with the equipment. Next, you might also collect the patient's electronic health record, known as an EHR. You collect this in order to view the doctor's treatment order, when the treatment order was made, how the treatment order was made, and the clinical notes relating to the incident. Finally, you should also ensure that any records available from the machine itself have been captured. These could include a log of the treatment instructions that were received from the machine, and the usage or operation log that details how the machine processed and performed the treatment. And that will include any errors that the machine's systems may have recorded at the time. All of these things together can help you build a picture of whether or not the operator caused the error, whether the doctor made an incorrect order, or whether the machine itself, something in the software or the hardware of the machine itself, in this case it was the hardware of the machine, was causing an error that resulted in it being wide open and over-irradiating the patient. This is now the end of our 3-part lecture on cybercrime and digital evidence. What will follow in your seminars is some fact scenarios from cases that have happened around the world that you can discuss and talk through and work out the digital evidence that you believe was available, how that digital evidence should be used, and then you can have a look at the actual case itself and find out what the outcome was. Thank you for watching these videos. I look forward to seeing you again in our next lot of lectures on law and technology.